That's all. Okay. So, yeah. So on a benzene ring, we just have to check what it does. Okay. Whether it is pushing the electrons in or whether it is pulling the electron out. Is it okay? So I
Yes, ma'am.
have put now 3 types of functional groups. Okay. I'm going to put one more. Let us assume I'm going to put a night amino group. So the NH2 group, so you don't treat it as an OH minus. You treat it as a functional group sitting on benzene. Clear? You will treat it as a functional group sitting on benzene. So what does it do? It will actually, it is ortho para directing. Okay. And it is activating. That means it will help the electrophilic substitution to take place. Okay, it will activate. It is activating. It is activating towards electrophilic substitution. So it helps. That means there are 5 electrophilic substitutions: halogens, halogenation, Friedel-Crafts alkylation, acylation. Okay, then you have got the sulfonation and nitration. So what is OH group doing? It activates. That means it enhances the reactivity of benzene by being present on it. And where will the incoming electrophile be taken? It will be taken on the ortho or on the para position. Is it clear?
Yes, ma'am.
Is it clear?
Yes, ma'am.
Okay. Right. Okay. Similarly, see, similarly, the chlorine here is ortho para, but it does not help. It is deactivating. So it does take it at ortho para, but it is not helping. It slows down the reaction. Okay. So we'll put them, we will keep them into 3 categories. This side, it is all electron withdrawing group: nitro group, COOH group, CHO, ketonic group, COR, cyano group. All these are electron nitro group. All these are electron withdrawing groups. All those electron withdrawing groups are also deactivating. Plus, they are meta directing. See, they are electron withdrawing, deactivating, meta directing. What are these? This side you have got electron donating groups, releasing groups. They are orthopara and they are activating groups. Got the combination?
Yes, ma'am.
Okay. The only exception is the chlorine, which is deactivating but orthopara directing. And it is electron withdrawing group. It's a rare combination. All activating groups are orthopara. All deactivating groups are electron withdrawing and meta. But this is the only one which is electron withdrawing but orthopara. So generally the rule goes like this: electron withdrawing group will push to meta. Electron donating group will push the incoming electrophile to orthopara. Chlorine is the only exception where it is electron withdrawing, hence deactivating, but it is orthopara. So don't treat OH as an OH minus. Got it?
Yes, ma'am. I
Okay.
understood.
Right. Any other doubt, ma, for you, uh, Rajesh? Did we solve all the questions, ma, from the text? All are done, na? This one we did, right? This one we
Yes, ma'am.
did. This one we didn't do, isn't it? This one we didn't do.
Yeah, we didn't do that.
N-butyl chloride is treated with alcoholic KOH. What will alcoholic KOH do? Aprameya.
Beta elimination.
Yeah, that's all. N-butyl chloride on alcoholic KOH. Okay. Now, Prajesh, you have to tell me the time for Sunday tomorrow. Which time you want
Yes,
me
ma'am.
to have a meet with you? For Aprameya, it is 8:30 a.m.
Confirm,
Sorry,
ma'am.
Sunday. Sunday it was. You will tell me your time. Okay. For either you give me a time on Saturday or on Sunday. Right?
Yes, ma'am.
Oh, right. Alcoholic KOH. What will it do? It will do beta elimination. Right. So this will give you the beta elimination. Is there any other option, Aprameya? Any other byproduct? Only single product will be formed, no? Because it is N-butyl chloride.
Yes, ma'am.
Okay. Bromobenzene on treatment with magnesium in the presence of dry ether. What do you think, Aprameya? Keep telling. Because Prajesh isn't traveling, so he will not answer. Now tell me.
Okay, ma'am.
Bro.
It will Grignard's region.
So
So
C6H5 MgBr.
yeah.
Okay. Chlorobenzene is subjected to hydrolysis. So I'm trying to hydrolyze.
So
And hmm.
ma'am, but then we need to like do it in
Yeah.
specific pressure and
Yeah. 623 Kelvin and
300
300 atm pressure to replace it with OH. But since we are using NaOH, this I told you will be in the form of O
O
minus
and
Na
Na
plus.
plus. So we
So
need
that
that H plus also. So.
yeah. See, this is the key. If you keep reading again and again, you will be so familiar that your mind will now go to application questions. But if you're struggling with just recollection of the ideas, then recollection of the equations, then you cannot do that.
Yes, ma'am.
Okay. Ethyl chloride with aqueous KOH. What does
So
aqueous KOH do?
it will become ethanol.
That's all. It will become ethanol. Ethyl chloride will become ethanol. Methyl bromide on treatment with sodium in the presence of dry ether. See, whenever you are seeing a reaction, look at the reagent. Then
Is
only
it
go
like
and see the
worth
reactant. Yeah. So
Oh,
what will
okay.
happen? Methyl bromide is reacted
So we need to
with
take
words.
two
Yeah. What will you get? You'll get CH3, single bond CH3, right?
ethane.
Yeah.
Yes, ma'am.
Methyl chloride on treatment with KCl.
You get CH3CN.
Yeah. What if it had been AgCl?
You get CH3NC.
That's all. This kind of familiarity, if it is there, then subsequent work will become very easy. Okay. If you do, see, I won't say because of learning, this will come. This will come by, no, sitting and challenging yourself whether I am able to think these questions or not. But at least others you can definitely do. Okay. This part is also done, I believe, right? This we did.
Yes, ma'am.
So we have finished all these. So I'll
Did
still
we do
want
the
to spend,
I don't.
sorry,
11.
which one? 11th. Okay. 11th is again conversion question.
Oh,
Shall we do
right.
it? Yeah. We'll
I
do.
think it's the Oh, fine. Okay. I don't
11th is,
remember doing it. 1 second, I'll check.
yeah. No problem. No, we have not done. We have not done.
Yes, ma'am. We didn't do it.
Mm. Okay. So let us try doing the 11th one. Okay. Question number 11. Question number 11. The first one is ethanol. CH3, CH2OH. I want to spend some more time so that no, you people become very comfortable with this lesson. Upcoming lessons we can do little fast. Okay, you want
Yes.
CH3, CH2, C triple bond CH. Okay, so this must be the same, na? Butane.
It
This
is
is
the
a
11th. Yeah.
So we can first convert it to CH3CH2Cl by treating it with SOCl2 and treating it with CH triple bond C minus Na plus, right? Which acts as a nucleophile and attacks the C minus attacks the chlorine, goes off with sodium, and you will be getting the desired product plus NaCl. Okay, you need to plan. Like no, in from the starting material, you can get the 2-carbon chain, which is already there. Okay. So you need to bring the rest of it, bring it in the form of a nucleophile. This can be used to increase the carbon chain length. Fine, ma? Okay. Second part, can we go?
Yes.
Second one. Okay. What was that? Ethane to bromoethene. CH3 single bond CH3 to CH2 double bond CHBr. This is completely motivated from the 11th standard. Completely. Okay. So I'll tell you what to do because it's way long. You don't have to introduce any carbon reagent, correct? 1 minute, no? 1 minute. Okay. So what to do? See, can we think that this was actually CH triple bond CH to which we have added 1 mole of HBr? This is one
Yes.
another way to think. Okay, how do you introduce a bromine? Maybe it was a triple bonded compound. You add HBr, and when you add HBr, you get the bromoethene. H adds to 1 and Br adds to H adds to 1 carbon, H to 1 and Br to another, and you get the product. Fine? Okay. So now
Yes,
the
ma'am.
question is, how will you convert this into this? So what you
Can
can
we
do,
eliminate the hydrogen?
first can we remove the hydrogens? But how do you remove the hydrogens? Have you learnt any dehydrogenation reaction? In any case, are you able to remove? You see, if you have an alkene, you can convert to alkane. Alkyne, you can convert to alkene and then alkane. But was there any way to convert alkane directly to alkene? No. So what we
No,
will do,
ma'am.
I'll tell you and capture this. Treat it with Cl2 in the presence of H nu to get CH3 single bond CH2Cl. CH3 CH2Cl. Free radical halogenation. Now you take out the use alcoholic KOH to remove HCl. That means you are going to get CH2 double bond CH2. To this you add Cl2. This we have done in last year also. CCl4 acting as a medium, just addition reaction. So CH2Cl, CH2Cl. To this, if you are going to add, or you let me add Br2. Okay, so you get Br and Br and Br. Okay, now if you take alcoholic KOH, you can straight away get this because you would have removed 1 mole of HBr, correct? Correct? Is it not again beta elimination? Hydrogen from here, hydrogen, and the Br from here will convert it into bromoethene, no?
Yes, ma'am.
Okay, or if you had done 2 times HBr elimination, that means you use NaOH alcoholic followed by NaNH2. You remove 2 HBrs, then you get an ethyne. To that you add 1 HBr to get the bromoethene, either this way or that way. This is something which,
Yes.
from class 11 it continues. It can be like from any say some question may be there from ethene. How will you convert ethene into bromoethene? You cannot do directly free radical halogenation. So you'll have to do it this way only. Add bromine, remove 1 HBr. Is it okay?
Yes, ma'am.
Okay. So that was something. Have you copied this?
Yes, ma'am.
The third part, propene to nitropropane. It's propene to nitropropane. Nitro group here. So what do you have to do? Is there any way of adding nitro group on the double bond? Is there any way of adding? No way, na? You could add
No.
only HBr, Cl2, Br2 or hydrogens, right?
Yes, ma'am.
Okay, but we know that if you have an Rx, you can treat it with AgNO2 to get an RNO2. Remember that from the
Yes.
text? From the text, remember ambident nucleophiles. If you treat it with KNO2, you get RONO. Remember that? Potassium is ionic. NO2, the negative charge lies on the oxygen. Negative charge lies on the oxygen and attack is through oxygen to get a nitrite. But the bond between Ag and oxygen is a covalent bond. So the attack happens through nitrogen. So now R is getting connected to nitrogen. So does it not look like if you want a nitro compound, then you should have in the starting material one halogen.
Yes, ma'am.
So, and where do you want the halogen? Where do you want the halogen? On the first carbon, na?
Yes, ma'am.
So what do? You add HBr in the presence of peroxide. What will you get? You will get Br on the first position, antimarconic of addition. Now treat it with AgNO2. Is that okay? Is that okay?
Yes, ma'am.
Next one. Toluene to benzyl alcohol. Come on, this we have already done. So try. Toluene to benzyl alcohol. You cannot introduce OH directly. But if you have a halogen, you could have replaced. What do you have to do then? Yeah, what happened? Pranav forgot. Pranav? Yes, Pranav. Am I audible? Pranav? Aprameya audible?
Ma'am,
Okay.
he's
Yeah. Okay.
messaged in that chat.
I need to fix my microphone. So my question is, did you forget Pranav?
He's messaged
Okay.
saying he's outside on that chat.
Okay. Cherry, so think about this, children. Yes, ma'am. Okay. Fine. Ah, tell me. Tell me. And OH can be placed in the place of a halogen only, no, Aprameya?
Yes, ma'am.
So the idea is first you introduce a halogen. How do you introduce halogen on the side chain, Aprameya? If you want to introduce halogen on the ortho or para position, you do electrophilic substitution.
Yes.
But if you want to do it on the side chain, what will you do? You can type if you want, Pranav. If you want to introduce a halogen on the side chain, how will you do it? If you want
Can we do
the
BR2?
huh?
Can we do, I'm not sure if it's right though, BR2 and um,
See, Br2 in the presence of FeBr3. This will become Friedel. This will become this
not,
electrophilic halogenation, electrophilic substitution. Now you'll get ortho and para product. Correct. But do you want that? You want the OH on the carbon, on the side chain carbon. So your duty is to put the halogen on the side chain. How will you do that? How will you make it into something like this, CH2Br? Because I know that after this it is easy, aqueous
free
NaOH.
radical halogenation.
Yeah, free radical halogenation. So better to put a Cl2 in the presence of UV light. So you get Cl and treat it with aqueous NaOH. It's actually very fast hydrolysis. Why? Because we know benzylic carbocation, benzylic, allylic, and tertiary carbocations are very, very stable. So this will undergo faster hydrolysis. Just with aqueous NaOH, it will get clear. So you don't want these products, so ignore them. Clear?
Yes, ma'am.
Okay. See, we are spending more time for this lesson to sink in nicely. Okay. Otherwise, the other lessons will become very difficult. Propene to propine. I'm doing the fifth one. Propene to propine. CH, C triple bond. See, remember just now I told one way to convert double bond into triple bond. What was that? You can apply that. See, this from this you can take the hint. How would you convert double bond into triple bond?
BR2 CCl.
First, you add Br2, provide a vicinal dibromo compound, and remove two HBrs. H from here, Br from there. Okay, H from here, Br from here, and H from here, and Br from here. So, remove two moles of HBr to get you the triple bond. So, can you employ the same thing here also? What to do? First step. First step,
BR2 in the presence of C.
Br2. Br2 as CCl4 taken as a solvent, not much. Okay, then this will become 1, 2 dibromopropane, CH2Br. And then to this you add alcoholic KOH. You remove the first HBr, you will get CH3. So I'm wanting to remove the first HBr. So I'll remove from here. So I'm going to remove this H and this Br. I'm going to get CH double bond CHBr. Now I'm going to target the second HBr removal by using even a stronger base like NaNH2. Okay, NaNH2. So what do we do? This hydrogen with this Br. So I get propyl. Is it clear? Okay. Next one, can we do? Prameya?
Yes, ma'am.
Sixth one, ethanol to ethyl fluoride. CH3, CH2OH to CH3, CH2F. Now we know fluorine is introduced in a carbon compound by one name reaction. What is that name reaction?
Swartz.
Swartz. But for Swartz, what is the starting material? You would have written
Metallic fluoride and
either a bromide or a chloride, right?
yeah,
RCl or RBr on treatment with
that's
AgF,
BF.
okay? Or your cobalt fluoride or mercuric fluoride will give you this product. So, but still, that means you need CH3, CH2, Br. So, how do you convert alcohol into Br? Hmm. How do you convert? So many ways. The first set of reactions, SOCl2, ZnCl2, HCl,
NaBr plus
NaBr and H2SO. Is it must that you should make it only a bromide? Why not chloride? In that case,
we
you
can
can
do
take
SOCl.
SOCl2, anything, PCl5, PBr5, anything will help. Is it okay? Okay, next one.
Yes, ma'am.
Bromomethane to propanol. This is out of your range now. This needs something more. Okay, this is out of your lesson. It cannot be done right now. We are, but actually, how do we do CH3? C double bond OCH3. Of course, not at all required. You make it attack. First, you convert it into Grignard and make it attack on a carbonyl carbon, that is ethane, ethanol, and convert it into secondary alcohol and then oxidize it. So that's why I'm saying it is out of the question now. PCC and it will convert it into C double bond or CH. Idella, you will get it in the subsequent lessons. So you be comfortable with this lesson first, then we can do others. Because all the 4 lessons are full of reactions. You have to be comfortable with all the reactions. How do you get that? First understand, then work on your memorization.
Yes, ma'am.
Now see, but 1-ene to but 2-ene. What do you have to do? But 1-ene to but 2-ene. First you how
We
is the
can
double bond? Add very good. Add what?
HBr or something like that.
Yes, HBr.
So that
Okay.
we can get the Br in the last position. That is the first.
No.
Oh, sorry.
இங்க வரணும்னா திருப்பி double bond எங்க வரும்? On
Oh,
elimination.
right. Sorry.
Double
we
bond
need
will again be formed here, no?
Yes, ma'am.
So normal HBr. So positive part goes to this carbon and negative part here. So the bromine gets attached here.
Yes, ma'am.
And then
Thanks.
again do alcoholic KOH. Yes, Pranav, is your mic all right? Is he there?
Yes, ma'am, it is.
Uh-huh. Okay. Okay. Mm, okay, fine. Then 1-chlorobutane to N-octane. Think about this. 1-chlorobutane to N-octane. Does it not sound very familiar? What is this?
Woods, yes.
It's Wood's reaction. Because you have 1, 2, 3, 4 carbon compound. Change it to 1, 2, 3, 4, 5, 6, 7, 8. Double, exactly double. That too with simply. So you will just have to take the 2 moles of this, 2 moles of sodium dry ether and react to make the octane. Fine. Benzene to biphenyl. This also we have thought. Try to recollect what we thought. This is your biphenyl. What can be done? What is this reaction which gives you this product? Think in that way.
Fitting
Phytic. But what is the starting material for phytic?
halogen.
Halogen. There is no halogen here. So what do you have to do first?
Halogenation.
First halogenate it. Right? So what do you do? Cl2 in the presence of FeCl3. That you get the halogen. Okay. Then what? Take 2 moles of that, 2 moles of sodium, dry ether, and perform the Wood's Fittig reaction. Is it okay? Okay. We'll go to this. Okay. I'll treat this as the last class for this lesson, children. Please work. And Pranav, you have not submitted the first test paper also. Actually, I'm going to make another paper for Aprameya. Do you want to take that test?
Oh, okay, ma'am.
Okay. That test you take. Okay. Aprameya, and when will you want to take?
For
from
which
solution?
chapter? Solution.
Solution, yeah.
Um, maybe next week, ma'am.
Next week, as
Or
far as
or
possible.
as far. Okay. I'll take it up this Sunday or
Is it okay,
Monday.
Pranav?
Yes,
I'll
ma'am.
give it by Tuesday, ma'am.
Okay,
I
fine.
don't know. I haven't.
Sir, I'll I'll post it to you. Okay, I'll post the
Ma'am, you
question
can
bank.
post it this Sunday, ma'am. I'll give it to you by
Okay,
Tuesday.
okay. Yes, Pranav, you will also take the test. Okay, and we will plan to conduct the test from this lesson also. Fine.
Yes.
Okay. Now coming to this. Look at this question. This is a 3-mark question. Think about it. 13th A. Identify the major product when 2-cyclohexyl chloroethane. So you always start the structure writing from the last. So it is ethane, a 2-carbon, 2-cyclohexyl. Assume this is first carbon, this is second. 2-cyclohexyl. Okay. 2-cyclohexyl chloroethane. So chlorine is present on the first carbon. That means this is the compound. Correct? Correct? 2-cyclohexyl chloroethane. So chlorine must be on the first carbon. Now this is undergoing dehydrohalogenation. Dehydrohalogenation. Halo. Dehydrohalogenation. So name the reagent used to carry out. What is the reagent that causes the removal of HCl, children? It's a simple question. They didn't ask you the product. Oh, identify the major product. Tell me. What is the major product? You have to remove the HCl. That's all. Tell me what it is. Aprameya.
Sedensity.
Illama, you are removing
Oh, removing
HCl.
the.
Yeah, is it not beta elimination?
Yes, ma'am.
Then what is the reagent for beta elimination? Beta elimination. Pranav.
KOH, ma'am. Sorry.
Alcoholic KOH, na?
Yes, ma'am.
So what do? You remove the beta from the beta position hydrogen. Okay. Electron pair kicks in and the chlorine is sent out. So what will you get? No benzene. It is CH double bond CH2.
CH. Yes.
Cyclohexyl ethene. Very simple question. If you
Yes,
know
ma'am.
the concept, you can start applying. Okay. Name the reagent. Reagent is alcoholic KOH. Okay. B part. Why haloalkanes are more reactive towards nucleophilic substitution than haloarenes and vinyl halides? What is the problem? The same concept is again and again tested. See, CH2 double bond CHCl. That is your vinylic. Vinylic is when the halogen is directly present on an sp2 carbon of aliphatic system. So why do you think? Partly I have told
Because
you.
yes, ma'am. It's because in haloarenes, it's we have that four reasons, right, ma'am? Like
Yeah.
it's like
The
it
first
is
thing, the
electron
sp2
rich
carbon.
and it has a different hybridization. So
Yeah.
and
So
also yes, ma'am. And also both of them are like also
can we say resonance is going on?
yes,
So
ma'am.
there is a shorter bond. There is a shorter bond. This bond becomes a shorter bond. Yes, Pranav? The chlorine is held to an sp2
Yes.
carbon, so it's a shorter bond. Difficult to break a shorter bond. Moreover, there is a resonance. How there is a resonance? See here. There is a resonance. See, whenever a lone pair double bond or double bond double bond is separated by a single bond, or lone pair and double bond are separated by a single bond. Resonance is possible. So here also resonance is possible. See, what will happen? You will get CH2 minus, single bond CH, double bond Cl plus. So there is a double bond character, which is difficult to break. Double bond is difficult to break. The 4 reasons, the famous reasons, don't write 4 reasons, write those reasons properly, okay? So both in vinyl. Only thing is we will not write about the possible repulsion. Here we will speak about the carbon is sp2, carbon holding the halogen is sp2. So the double bond character sets in, the resonance is going on, difficult to break, all those things you'll speak. Okay. Then it is not possible for phenyl carbocation. SN1 reaction cannot happen. The chlorine cannot take off. The phenyl carbocation is unstable. The chlorine cannot take off because the vinylic carbocation is unstable. Clear? Do write, children. In the idella எழுதுனாதான் you can be comfortable when you write. See, if you keep listening to, yes, fine. But when the time arises for you to write them, you have to write it properly. Okay, so almost same reaction, almost same thing. The same question. Name the possible alkenes which will be obtained by one. See, it's I or question. Maybe in the same year, 2 different sets had got different questions. And it's very nice. Please plan for this A. How is it different from 2-cyclohexyl chloroethane? Check this. 1 chloro, 1 methyl cyclohexane. Plan for this. Start always from the last. It is cyclohexane. Cyclohexane. On the first position, there is a chlorine. On the first position, there is a methyl group also. Okay. On their reaction with, name the possible alkenes which will yield. Oh, which will yield. Oh, which will yield. Name the alkene. Which alkene is going to yield this on treatment with HCl? Plan. Think about it, children. Suppose I'll just give you an example. Supposing we have a double bond here and you add HCl, then Markovnikov addition will add the Cl to the middle carbon, hydrogen to the last. So if I do not give you this, will you not be able to predict what should be the starting material?
Will it be toluene?
There is no benzene in it. So no question
Right,
of
sounds
toluene. Yeah. See, by looking at the product, can you not predict where the double bond should have been? The double bond should have been on the 3 carbon. Where should the double bond be? Whether it is here or here, you are going to get the same product, no? Either way, it is 2-chloropropane only, no? So this, where do you want me to put the double bond? So what you do is remove the halogen first. Okay. Keep all the carbons. Now you start putting. If the double bond, the chlorine should attack here. So the double bond should be around this position. That means you can plan a double bond here, or you can plan a double bond here, or you can plan a double bond here. Whether you plan it here or here, they both are identical. So you take any one into consideration. So this one, or it could be the other one. Think about it. If you add HCl, will you not get this product, children? Think
Yes,
about
ma'am.
it. See, what you do in such cases is you think about something very simple and trivial. From there, you try to get the ideas also. Understood? So I just recollected a simple equation. Oh, if I want 2-chloropropane, where should the double bond be? So I planned that way. Now, it should be around this carbon. So I planned the double bond on this side or on this side. So same thing, this carbon has got the halogen. So plan the double bond around this. So one is having it here. The other one will be to have it there. Or the other one will be to have it here, which are both identical. So any one you take. Okay. Clear? Approach is clear? B. Allyl chloride is hydrolyzed more easily. What did like Rhines we were telling one statement. Why allyl? Allyl comes into which part? What is the relevance of allyl? Hmm. Why couldn't vinyl undergo the substitution easily? Why couldn't the vinyl undergo the substitution easily? If you take
Yes,
aqueous NaOH, because of the sp2 carbon, na? And
yes,
because of possibly the resonance making it a double bonded one. What makes allyl? What is allyl? This is allyl, na? What makes
yes.
allyl so easy?
It's
Pranav, tell me.
SP2.
sp2. What else? It's even better than N-propyl bromide. Why? It's fastest in this case. Why? If you have missed this, it is very, what do you say, careless approach. I have been telling you, allylic carbocation is stable. Benzylic carbocation is stable. Benzylic carbocation is stable. Tertiary carbocation is stable. Correct? So wherever there is a chance to give out the bromine, what will the allylic bromide do? What will it do? It will allow the bromine to go out. If it allows it, then there is a carbocation formation which happens to be very stable. Allyl, benzyl, tertiary. Please remember, allyl, benzyl, tertiary. These three will form a stable carbocation. Not only that, they form stable radicals also. The behavior of radical and carbocation is both same. So they will undergo the substitution as well as free radical halogenation very easily. Take it once for all children. Yes?
Yes, ma'am.
Okay. Yes, boys, both of you.
Yes.
CH2 double bond CH2Br. If you subject it to aqueous NaOH, then it will choose whether to go for SN1 or SN2. This is primary, no doubt. But if the halogen is allowed to move out, it will become a carbocation which gets resonance stabilization. So it moves to SN1 and the reaction is very fast. Same is the case with benzylic CH2Br. It's primary. The halogen is connected to a carbon, which in turn is connected to one more. But then, because it can form a stable carbocation, if the bromine is allowed to go out, it will form a stable carbocation, which gets resonance stabilized. In the case of a tertiary also, it is happening. Why? Not because of the resonance, but because of the 3 plus I groups. All the 3 plus I groups will favor the formation of a carbocation. So if there is allylic, the word allylic, okay, benzylic and tertiary should immediately take you to stable carbocation or stable radical. The aryl and the vinyl should ring a bell in your mind that there is the nucleophilic substitution is very difficult. Please note it down and please put it in your mind, children. Is it clear?
Yes, ma'am.
Yes, Pranav? The moment allylic
Yes.
benzyl and Prajesh, please see that these three ring your bell pertaining to carbocation stability, radical stability. Most likely the question will be about that. And the moment it is aryl or haloarine, chlorobenzene, chloroethene, chloroethene, chlorobenzene, then the nucleophilic substitution is difficult for many reasons. This is the most important concept in this lesson. And the moment there is allylic, benzylic, or tertiary carbocation, SN1. Even though allylic may be primary, benzylic may be primary, tertiary is tertiary only, of course. SN1. Others will undergo SN2. Aryl and vinyl will resist even that. Okay, so that way you'll have to start thinking. Okay, very, very common questions they are all. Okay, very common questions. If you have answered one section, you will find again and again the same thing. Okay, 12th question. With the help of resonating structures, explain the effect of presence of nitro group at ortho position. So what will nitro group do? Nitro group facilitates the reaction, correct? Nitro groups helps the reaction to happen, correct? Well, how does it help the reaction to happen? How does it help? I'm putting the nitro group on the ortho position of the chlorobenzene. So what will it do? N, extend this bond. Don't draw many structures. What will it do? Because with the help of resonating structures, explain the presence of nitro group on ortho position. What does it do? When an OH, a nucleophile, an external nucleophile attacks, when an external nucleophile attacks this position, the double bond shifts in between the two, and this double bond in turn is pushed over to the oxygen. One structure you write and explain, that's it. So what will happen? Chlorine. These two double bonds not at all changed. Nucleophile is attached. This double bond is no longer there. Where is it? It is between carbon and nitrogen. This double bond no longer there. It is as O minus and coordinate bond. See whether you are comfortable with these changes, children, in the structure.
Yes, ma'am.
If you want, please write it once and see. But this is only structure. We have not explained. What will you conclude? You will say that nitro group on ortho position stabilizes carbanion produced due to attack by nucleophile. That's all. That's it. Very difficult. Hmm? Tell me, children. Or you can say that nitro group is electron withdrawing group. Thus, it increases the positive charge density on benzene ring, which helps the nucleophile to attack, which helps to attract the nucleophile. These are the two concepts involved in it. That's all. Very difficult, children. With very few words, very few structures, you can complete this answer. They may ask you why nitro group on meta position will not help. Then you will have to say that when we write the resonance structure, the negative charge never comes to the meta position. So having a nitro on the meta position does not help. That's all. Actually, these questions will be definitely there in the test. Please do. And also Pranav, Last class, you were not there, I think, right?
Yes.
What we decided is that either Saturday, tomorrow, have you learned this lesson, Pranav? You have already written a test from this lesson,
Yes,
probably in your
ma'am.
school. Yeah. So either on Saturday or on Sunday or on Monday, you have to tell me which time to, like, no, evening. I'll tell my free slots. You will please call. I mean, we will have a one-to-one interaction. Okay. So when I interact with you, nobody else will be there. So
Okay.
learn and come. It will be like a viva from this lesson. Clear?
Yes, ma'am.
Hmm. You both are yet to tell me your time, Prajesh and Pranav. Okay. After this class, take 10 minutes time and message me. Okay, Prajesh?
Can you come again, ma'am? I didn't hear like the last sentence
Uh,
alone.
around by 7:15 today. Now it is 7:01. At 7:15 p.m., tell me what time we can have the interaction, Saturday, Sunday, or Monday. What time we can have the interaction, you'll have to message me, I'm saying. Now, okay,
Okay, ma'am.
7:15, you can message. After the class, you will forget. So I'm telling you, after the class, you immediately start thinking about which time you are comfortable. Message me that time. Clear? Don't feel the pressure of it. Prepare and come. If you want some more days, also you take. Fine.
Yes, ma'am.
Okay. Okay. Next one. Carry out the following conversion not more than 2 steps. Aniline to chlorobenzene. Aprameya. Is it not a direct reaction? Like no.
Science.
So first you do treat it with
Yeah.
NaNO2 and HCl, or actually HNO2. Sometimes in the exam they may directly say HNO2. So you make diazonium chloride. Okay. And then treat it with Cu2 Cl2.
CuCl2.
If you are comfortable with all the equations, then we can plan all these questions. 2 bromopropane to 1 bromopropane. 2 bromopropane to 1 bromopropane. What do you have to do?
Remove the HBr using
Hmm.
beta elimination, and
Hmm.
then again do HBr addition.
In Markovnikov or anti-Markovnikov way?
And
Hmm. So add HBr in the presence of peroxide.
peroxide.
Okay. Is it clear?
Yes.
Okay. I'm leaving this worksheet to you, children. Do it on your own. Okay. Same molecular formula but different structures.
Isomers.
Okay. Is A, and non-superimposable mirror images is B. Same molecular formula but different structures are isomers. Non-superimposable mirror images will be enantiomers. Na? So it should be
Yes, ma'am.
isomers and enantiomers. Okay.
Ma'am, can you send the exam idea to me, ma'am?
Yeah, I have sent to all. I've sent to all. See, Pranav, I've sent it. Okay. And the worksheet also I've sent.
Ma'am,
That
could you
PYQ
resend?
worksheet.
I didn't get it
Now
exactly.
I have sent. Oh, what happened? This is not going. Something went wrong. Sorry, I'll send it again. Okay.
Okay.
It may go. I think I'm using the net now, na? Probably. Rajesh Kwandachama. Rajesh, check.
That's the one you sent earlier, no, ma'am.
1 minute. If not, then I will send it by. Yeah, it is. I think I'm using the net. No, so it's probably not going. So otherwise, you send me your mail ID. Pranav, I have your mail ID. Rajesh, you send your mail ID. I'll send it. Okay.
Yes, ma'am.
Or probably after the class, it will go. Okay. Okay. So work on this lesson, children. Fine. From next class, I'll be starting the next lesson. Okay. Okay. Now tell me, Pranav, What is the lesson that they are doing now?
Ma'am, they're doing solutions.
And Rajesh, what for you?
For me, they've completed solutions in Halo Alkyls and Halo Rings. Now it's summer break now.
Okay, 2 lessons. Pranav, alcohol's over, Amma?
No, ma'am. It's summer break for
No.
me as well.
Okay. Apo, shall we start with electrochemistry then? The second lesson? And then
Yes,
you
ma'am.
take some time for organic. I'm saying take some time. Otherwise, what will happen is if you do not enforce the first lesson thoroughly, it's not about the reactions. There are very few reactions in this. But if you do not orient yourself properly towards learning it, then subsequent lessons will become only burden. So I want to wait for you people to complete this lesson comfortably. I don't mind starting alcohols. What do you all say?
Ma'am, I'm okay with anything. Because they're in a different chapter in our school.
Yeah, for you
They're
it is
very
DNF
ahead.
block.
So,
Hmm.
yes, ma'am, they are going to start
Yeah,
coordination after June.
Okay. What do you all say? Shall I start with that?
Yes,
Electrochemistry,
ma'am.
or you want me to go to alcohols?
Anything's fine.
Anything. Okay. Right. So I'll start with the electrochemistry in the next class. Okay. You please learn this lesson again and again. Thoroughly do all the worksheet. Then we will come to the second lesson of organic. So after electrochemistry, we'll come to alcohols only. Okay. Yes, children. You can leave. If you have doubts, you ask me now. Otherwise, you can leave.
Thank you.
Thank you.
Yes, ma'am.
Thank you, ma'am.
Yes, ma'am.
So the test வந்து on Monday, like
I'll start preparing. As soon as I prepare, I'll send it to you. You take the test.
yes, ma'am.
Okay.
You just let me
Right.
know the date, ma'am, so that I can be like. Actually, I think at that time when you sent the test, right, ma'am,
Mhm.
I thought I had to submit it on the deadline, and also I had a lot of tests in school, and நீங்க
No
கொடுத்த
problem.
அதெல்லாம் ராதா மேமும் கொடுத்தா எல்லாருமே ஒரே
Hmm.
நேரத்துல கொடுத்ததுனால I couldn't study properly, so
Okay. Okay. No problem. You learn. நீ ஒண்ணு பண்ணு ஹாலோஜன் இது கம்ப்ளீட்டா படி ஐ மீன் சொல்யூஷன் தரவா ப்ரிப்பேர் பண்ணிடு
okay.
பண்ணிட்டதுக்கு அப்புறமா யூ டெல் மீ ஐ வில் சென்ட் த கொஸ்டின்
இல்ல
பேப்பர்
மேம் நீங்க அனுப்புறது அனுப்புங்க நான் ப்ரிப்பேர் பண்ணி
சரி ஓகே டன்
முடிச்சது
ஓகே ஓகே
ஓகே மேம் தேங்க்யூ மேம்
எஸ் மேம் பை